My name is Timothy McBride, and today I will be giving a talk on taming the chaos of JavaScript. So before we get into this, we need to ask ourselves, why is JavaScript chaotic? And the reason behind this is that JavaScript wants to be your friend. It wants to help you in situations where you've maybe made a mistake or something along those lines. The problem with this is that we always have that one friend, and it will sometimes help you when you don't actually want to be helped. So the topics we're going to look at today in terms of the chaos is type conversion, global scope leakage, automatic semicolon insertion, and the this keyword. To start off, we're going to look at type conversion. There are two main types of type conversion. We have implicit conversion and we have explicit conversion. In implicit conversion, it's normally referred to as coercion and not conversion, whereas with explicit conversion, we're referring to casting. So what we have on the screen right now is we have three operators. In these three operators, it is usually where some form of implicit coercion occurs. So you've got our exclamation mark, our plus, and our minus. Let's take a look at some examples of how these have an impact. So what we've got in front of us is valid JavaScript code. And it doesn't necessarily look quite right. But through the use of implicit coercion, we are able to convert arrays into strings, and then we're indexing at certain positions. We're also converting arrays into numbers and so forth, or so on and so forth, to get to the point where we actually get the result of that this code here is the string fail. It doesn't quite make sense, but that is the case. Let's go back to some basics. So we know true is true. We also know not true is false. And we also know that not true is also true again. It's starting to make a bit of sense. Let's take it up a notch. We have not of 0 is false. Not of an empty array empty string is false. But not of an empty array and not of an empty object are true. Huh? Okay, taking a step back, going back to some basics again, we have 1 plus 1 is 2, but 101 plus a string of 1 is 1011. 101 minus a string of 1 is 100. 1 minus a is nan. And here's a bit of a question for you. What is b plus a plus b plus a? And the answer is a banana. So these aren't really real-world cases. For the most part, they don't come up that often, or do they? Let's take a look at our demo and find out. So for our first demo, we've got an array of plays here. And in these plays, or in this array, we've got various objects of the type of play. It's got a name, so Romeo and Juliet, a price per performance. In this case, we're looking at 20 Rand or 20 something, then genre and some actors. And we repeat this a couple of times, so we have multiple plays. Then we have a function called create statement. And in this function, we want to take in a play, the number of performances, and any additional costs. We check if the play is falsy or if it is an empty object. If it is, then we throw an error. After this, we decide that we're going to actually calculate the total cost per performance. So we take our play.price per performance, and we add our additional costs. Then we multiply the total cost per performance by the number of performances. We log the results just so that we can see what's coming out. The first time we run this, we're going to run it with our first play, which was Romeo and Juliet. It has a price per performance of 20. And we're going to say that there were 2 performances and there were additional costs of 5 Rand. So if we do this calculation in our head quickly, we know that the play.price per performance will be 20, plus the additional costs is 5, so it'll be 25 Rand per performance cost. then the total cost for all the performances, since there are only 2 of them, will be 50 Rand. Let's run this and see what actually happens. So if we run our example 1, we get back that the total cost is 410 Rand. That doesn't seem quite right. Then underneath that, we also get that the total cost of our second callout is nan. So what's actually going on here? And if we take a look deeper at our code, we can see that our price per performance in our array is actually recorded as a string of 20, but then when we're adding the additional costs, we're using a number. So this number is getting coerced into a string and then appended to the 20. So the total cost per performance is actually seen as 205 Rand, which isn't quite right. We then perform a multiplication on that, where it is getting coerced again back into a number, it's getting multiplied out, and we then get the result of 410. The second time we run this, we're running it on play 4, or on our 4th play in our array. And in this case, we're actually passing in an empty object. So we would have expected that this result would have been an error, that we would have thrown an error, because we're trying to check for that empty object. The issue is that the check we're doing doesn't successfully identify an empty object. It is actually seeing that objects as 2 separate entities and is returning false for this situation. If we wanted to actually check that the object was truly empty, one way we could do this is we could do object.keys for our play that we pass in, and we're going to check that the length is equal to 0. Quite a long statement just to check that the object has no properties in it. Then if we also want to fix the implicit coercion that's occurring here, something that we can do is we can take advantage of implicit coercion and use our plus operator to coerce that string into a number. I'm not trying to say that this is best practice or that you should be doing this. I just want to emphasize the point that this is something that you can do and that it is available within the language itself. So if we were to do this and actually run our script again, we get back that the result is actually correct now, that the total cost for the performance is 50 Rand, and then we're also getting our error thrown. The next thing that we're going to take a look at is our global scope leakage. One of the best analogies I can think of for global scope leakage is a leaky pipe, where the pipe itself is our local scope, and the water inside of that pipe is the data. When global scope leakage occurs, it is where the water is leaking out of that pipe and into the space around it. So we're leaking data from our local scope into our global scope. If we take a look at this, in our second demo, we're following on with the theme of our plays, except we've made a couple of changes now. So the first thing that we've done is we're saying that instead of logging our results, we're actually going to take an array of statement, and we're going to add to that the different lines that we want to actually go into the statement. So we do this. We set the line to add to thank you, and we add it to our statement. Then we set it again to the total cost per performances. At the end of this, we return our statement, and we then log our statement out. So let's run this and see how it actually looks. And now we're getting back an array of thank you, thank you. So something isn't going right here. We were expecting something a bit different. And looking at what we've got, there's actually a typo in our code. We've misspelt line to add the second time we've used it. And what JavaScript has done is it said, OK, I can see that you wanted to declare this variable. I can see that you wanted to do this. You obviously just made a mistake and you didn't define it, or you didn't tell me that you were going to declare it. So I'm going to help you out here. I'm going to go and declare it for you. The issue with this is it isn't actually declaring it in our local scope. It's actually declaring it in our global scope, and this is how the leakage is occurring. So we're leaking this value and the data that is involved with this value up to our global scope. To fix this, we just need to add we actually just need to fix our typo, and then we'll have it working. But that doesn't necessarily solve the underlying problem. So what can we do to prevent this from happening? And one of the techniques is to use strict mode. So at the top of our file, if we use strict, or if we type the string use strict, the compiler will now know to run JavaScript in strict mode. And in this case, if we run it again, we get an error. So what strict mode does is it causes it to fail hard if the variable is undefined. The next topic we're going to look at is automatic semicolon insertion. In a JavaScript developer's life cycle, or in their years of developing, they will at one point face the question to semicolon or not to semicolon. And I'm hoping that by the end of this presentation, I may have an answer for you. There are three main rules behind JavaScript's automatic semicolon insertion. What it does is it will pass the document, and if there is no semicolon and it deems that one should be inserted, it will insert one. And these three rules define when this occurs. For rule 1, it can be broken into two parts, part A and part B. What rule 1 says is that if the parser encounters a token that is not within the context of the grammar or the current grammar, then it is an offending token. If that offending token is separated by at least a line separator in part or for part A of rule 1, then a semicolon is inserted before it. For part B, if that offending token is a closing brace, then a semicolon is inserted before it. We'll take a look at where some issues can arise from this in our demo later. Rule 2 is a little bit more simple in that it basically states that when the program has reached its end, when the parser has reached the end of the program and it deems that there is no more code left for it to pass, then it will insert a semicolon. Lastly, for rule 3, this is a bit more of a complex one in that it says that if there is a line separator following a restricted production, then a semicolon is inserted. When we talk about restricted productions, we're referring to the words or the terms continue, break, return, throw, and yield. Now, if we go to our demo and we take a look at our third example, we're again continuing with our play theme, as is a recurring situation in this presentation, except we've made a couple of changes here. We're now wrapping our create statement function in an immediately invoked function, and we are awaiting a promise for a timeout. This is just to represent some delay, perhaps calling from a backend server or something along those lines. Then inside of our create statement, we're also taking a merchant name. What we're doing with this is when we return our statement, we're actually, instead of returning the statement array that we had previously, we're now returning an object with the merchant name and then the statement with it as well. So that way, we get back a name and a statement so we can easily identify which statement belongs to who. So if we run this now, and let's just run it and see, we're getting back a compile error. It's giving us this very long type error response saying that intermediate value, parentheses, intermediate value, dot, 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 etc. is not a function. And it's also pointing us to our immediately invoked function at the start of it. Now, if we take a look at that code looks correct. There's nothing out of the ordinary on this line. It's the correct syntax for creating an immediately invoked function, and it doesn't seem out of place. The issue that we have here is that JavaScript does not see this as an offending token. So it is not inserting a semicolon before it, even though we have multiple line separators separating this and our previous line. So the fix here is we need to add our semicolon. If we add our semicolon, save, and run it again, we now get back a returned response of undefined. So the program still isn't working quite correctly. What's happening here is coming down to our rule 3. And what rule 3 is telling us is that a semicolon is inserted after restricted productions, including return. We have a return statement here. We have a new line following it. So a semicolon is inserted right here. We're not actually able to return the object that we wanted to. And this is just based on a standard formatting. To fix this, if we pull our opening brace to the top of the return statement, or to the same line as the return, and we now run it, we'll get the correct response. So the question comes in is, what can we actually do about this? How can we deal with these issues? And one of the most obvious answers is insert your semicolons. If you insert them, you're less likely to come across these issues. If that is too difficult, there are linters and things like that which can be used to insert semicolons for you. And in those situations, you'll immediately get feedback when you save your file or when you run your lint or your linting that the program is incorrect or that something is out of place. The last point that we're going to look at in the chaos of JavaScript is the this keyword. And for the this keyword, we have a picture of a developer here trying to figure out what it is, because it can be various things under different contexts, and sometimes you just don't know what it is. To put it simply, what this is it is always referring to the calling context object. So where the function is called from, what object it was called from, where this was referenced. Let's take a look at our last demo for this situation. And we've got a slightly different demo now. We're still keeping to our play theme. However, we've got a couple of perform play functions. And the first time, we're just logging this. So we're taking an account value, and we're logging count in this. The idea behind this demo is to show how many times we can make this different. So as we go through this, try count and see how many times you can pick up where this will be different. So the first time we're doing it, we're just performing, we have a perform play function, we take an account, and we log this. The second time, we have a constructor function here called create play, and we're just defining our play. So we take in a name, a ticket price, and we're saying this.name equals name, this.ticket price equals ticket price. We then have a perform play function on this constructor function, or inside of it, and in that function, we're going to log this. Then we have an inner function inside of that, where we're going to log this again. We then call the inner function. So we use the constructor function to create the play hamlet. And after this, we have the last object, which is Romeo and Juliet, where we just have a directly defined object with the name Romeo and Juliet, a ticket price, and a perform play function. In this perform play function, we're again going to log this. So to just go through the steps as we call these, the first time we're just going to log this at the very base before we do anything else, just to get context of what this is in this current scope. Then we call perform play the second time, or the second time we're logging this. And this has no calling context object. It's just straight perform play. After that, we're going to use perform play, but we're going to use the call function to tell it that we want to use this with the object Romeo and Juliet. And we're going to see how that works. Then we call the hamlet.performPlay, and last we call Romeo and Juliet.performPlay. So if we run our last demo here, and we see what happens, we're getting back not quite what was expected. So the first time, we're seeing an empty object. Then we are seeing a global object. The third time, we actually get the correct response. Since we called it with Romeo and Juliet, we're getting Romeo and Juliet back. On the fourth time, we do see Hamlet. But the fifth time, we see the global object again. Now, if you remember correctly, the fifth time was when we were calling the inner function inside of the perform play on the Hamlet object. Then the last time we run this, which is on the Romeo and Juliet object, we just get back an empty object again. And this is the same as the first time we called this. So if we take a look a little bit deeper at this and try to identify what's going on, when we run perform play for count 2, what we're doing is we're not defining or providing it with the calling context object. We're not providing it with anything. So it's automatically picking up the global object. So it's seeing the global object as the context to use it, that this would be. And that's why the this, in that case, is the global object. Then we've already talked a little bit about when we use the call function to call it with Romeo and Juliet. And as I mentioned, the call function defines this, or defines the calling context for a function. So we're calling perform play with Romeo and Juliet. Then on the 4th time, we did get the correct response from the Hamlet, or from Hamlet, but the inner function didn't work quite right. And to look a little bit closer at this, what's happening here is we're seeing the global object again. And it doesn't seem like it makes much sense. You'd think that, but we're inside of perform play here. Why are we getting the global object? And the issue that's coming up is that this inner function is still linked, or it's still getting called from the global object. It doesn't have a calling context when we run it here. So there's a couple of ways we could fix this. We could use the .call method that we used previously for Romeo and Juliet, and we would pass in this in the perform play scope. But a more simpler option to use is to use an arrow function. Now, arrow functions are special in this case. What arrow functions do is they actually allow you to, or they keep the this of the lexical scope. So they keep the this of the current scope that they are in when they are defined. So in our situation within Hamlet, when we use an inner function here, we actually then keep this if we're using an arrow function, as it keeps the lexical scope environment, or it keeps the this from the lexical scope. The next point that comes up is something else that didn't quite make sense, was the Romeo and Juliet .perform play. And the issue here is that we're actually using an arrow function. And as I mentioned, arrow functions keep the this of the lexical scope, or the scope where they were defined. And in the situation where we're defining Romeo and Juliet, that scope is actually our module scope, which is the same as when we logged this the first time over here. And that's why we're getting an empty object back. So what we can do to fix this version is we could actually just use the implicit function syntax. And if we use that, then when we run this, since we can run this again now, we should get that the results are as we'd expect. And they indeed are. So we're getting back Romeo and Juliet when we'd expect Romeo and Juliet, and we're getting back Hamlet when we'd expect Hamlet. To summarize some of the things that we've talked about, we've mentioned type conversion, where we looked at how different types can be implicitly coerced into different things that are not expected. We also looked at global scope leakage, where simply misnaming something can actually result in errors in your code. Then we looked at automatic semicolon insertion and how if you don't insert semicolons, for the most part, JavaScript will catch it for you and actually insert that semicolon. However, there are some situations where that doesn't happen, or where it inserts a semicolon at the wrong place. And these can result in some bugs. The last thing we looked at was the this keyword. And we took a look at how it can be very different under certain contexts. As when it's called based on the function definition or things like that can have a big impact on what the actual object is. The issue with what I've kind of talked about, though, is these are all very small issues. They maybe come up 0.1% of the time, particularly for experienced developers and things like that. If you're familiar with JavaScript, you would know how to catch these. So where is the chaos? And the question, or the answer to this, comes in as if you have a team with multiple junior developers and one senior developer, as you start getting more developers on it, these issues start coming up more and more frequently. They can come up in places that you weren't expecting. They can start essentially having exponential growth. And the answer comes in as, what can we actually do about this? So how can we tame our chaos? And we've talked a little bit about some of these already, but one of the first things is strict mode. We can use strict mode to force JavaScript to run at a higher level, or at a stricter level where it throws errors instead of just allowing things to fail silently. We can use linters and formatters to help us with those semicolon insertions. They can also be used to identify errors before they come up. There are plenty, and the list keeps growing as more and more libraries for JavaScript keep getting created. But there are lots of utility libraries that have been well tested and can help with a lot of these issues. Then the last thing is unit tests. Unit tests, as we can see from these examples, one quick run through of our code and we can identify that there's an issue. By having a good set of test cases and test suites, we can identify and pick up these issues before they become larger problems in production. So to look more at strict mode, what really is it? And what it is when it was released, the idea was that it provided a way for JavaScript to run at a stricter sense, at a stricter mode, where it fails harder, and it will fail in situations where it normally wouldn't have. It also changes the way that this is used, and I'm referring to the this keyword here, where it, in the global scope situation, in the case where you are referencing the global object with this, instead of referencing that global object, it will return undefined. Linters and formatters, there are tons of them. ESLint, Prettier, JSHint, etc. Benefits around linters and things like that is that they are fully configurable. So you can set the rules that you want to your team to abide by. You can define these rules and set them up. Once you have those rules, you can use things like Git hooks to enforce those rules, so that when your developers push up to a repository, that those rules are actually enforced and that they have to abide by them. Otherwise, the push will fail. Other options are to use your CI/CD pipelines. When you use your CI/CD pipelines, you can have it set up so that it validates that the linters are passing. And if the linters are not passing, then the pull requests cannot be merged in. This is there just to add that extra layer of security, that in case something does get through Git or something does end up on the repository, the online repository, that it never gets to your development or your master branches. There are also a handful of utility libraries, as I mentioned before. We have underscore or Lodash, which is a very useful utility library with functions like merge deep or clone deep as well. Another example is to check whether an object is empty or not. Then we have Ramda, which is a functional library to help with functional coding. It can help you with creating immutable objects that are truly immutable. And then there's also Luxon or Moment, which is a datetime library that can help with various dates and the date object within JavaScript. Lastly, unit tests. As I mentioned before, unit tests can help pick up these errors before they happen. And if you do have a number of junior developers on your team, having this well-developed set of suite of tests can help them pick up issues when they make changes, or if they go and fix a bug somewhere, or if they're adding a new feature. Having those tests set up and following a practice like test-driven development can help pick these issues up before they even become a big problem. Okay, so we're now going to take a look at our last demo. And for this demo, what we've got is we've got our previous examples, but instead of looking at them as how we can fix them in errors, we're actually going to show them with the linters and how the linters can enforce the different rules. So if we take a look at our first example, something we note here, there's no errors showing. The only thing we can really see that's wrong with this is that it's telling us no magic numbers. And this is just included here to emphasize the point that linters do not catch everything. So just because you have linters or just because you have these tools in place does not mean that it's not important to know about these situations and know how these things can come up or where they're coming up. One thing I will show, though, is that if we do put our implicit casting here and we save this, it's automatically changed to an explicit casting with the number option in our file here. Now let's take a look at our second example. Now, in this example, we had the issue with the undefined values. So where the errors came around from line to add, and that we'd actually misspelt the variable name. What we can notice immediately is that the linters are telling us straight away, line to add has not been defined, that there's no undefined, or that there's no value here. We're getting a red underline telling us it is not a good idea to have this here. So from that, we can immediately see, oh, we actually have a misspelling on this word. We save it, and suddenly we have a fix. Something else to note is we're getting at the bottom here, it's also highlighting, and this is because it also wasn't defined in the global scope. So we can delete this console log statement, and then we have a clean file. For example 3, where we were looking at the semicolon insertion, or the automatic semicolon insertion, we're getting quite a lot of errors here. We're saying expected indentation of 2 spaces, but found 4. We're also getting that at the bottom here, we're seeing that the nested block was redundant and that there's unreachable code. So let's save this and just clean some of these up a bit first. So once we've saved, we now see that our file has been changed quite significantly from the formatting. We're actually pulling our immediately invoked function here right up to our array, and that doesn't seem right. So as a developer, you would notice this and see, oh, something's not right here. I obviously need a semicolon. Save, and we're fine. The next point is, even though we've put that semicolon there, we can notice that on our return statement, the linter has automatically put that semicolon for us. So we can see that at this point, we're returning nothing. If we delete it and save it again, just to emphasize, it is doing that as expected. There's also a red underline on our object and on the properties inside of our object, and it's telling us that this code is unreachable. It cannot reach this code, and that's due to the return statement. So if we fix this and put our bracket on the same line as the return, hit save, we're still getting an issue. And what's happened here is that the linter, not understanding what was going on with our code when it was like this, has gone and put a semicolon on the statement property here. If we delete that and save again, we now see that it's put the semicolon in the correct place. Our last example was this example. And again, we're getting quite a number of errors here linking to our indentation and things like that. If we save it, those go away. But we're still seeing quite a number of errors here, and they all linked onto the this. They are telling us that the this in these contexts are unexpected. So in the first case, where we have perform play, it's telling us that there's no invalid this, that it's an invalid this. Same thing for our inner function. Now, if we change our inner function to an arrow function as before and save it, we remove those errors. We actually see that our this in this situation is correct now. The last point that we have is in our Romeo and Juliet object, and we've still got our arrow function here, and again it is telling us that there is an unexpected this, that it is referring to the global this, and we don't want that. We want this to refer to Romeo and Juliet. So if we use our implicit syntax, we then get that it goes away. So I hope that kind of helps explain how linters and these tools can actually help you. To kind of summarize on a standard practice or standard rules that you can follow to avoid these issues and avoid these kind of situations. The best thing I can say is you define your rules. Decide how you want your code to be structured. Do you want to use strict mode? Do you want to keep this purely to classes? Do you want to force constant lets? Are you going to use the rules where where it highlights this when it is invalid? Once you have these rules set up, create your workspace, set them down, get them implemented. Then you use linters and the various configurable properties with them to enforce those rules. I hope you all gathered something from this talk and you maybe got a bit of a sense of JavaScript and its wilder side. Before I finish off here, just a small disclaimer that I'm not trying to mock JavaScript or make fun of it. I actually really enjoy the language, and I think it is a really nice language to work in. But there are some idiosyncrasies that are important to be aware of. So I hope you all learned something, and yeah, thank you.